satellites, providing persistent coverage of waters surrounding China. These capabilities can also support targeting for China's anti-ship ballistic missiles, and with sufficient numbers of integration, they could provide real-time targeting triangulation data to build up a robust picture of target's location to ultimately generate a targeting approach. With this introduction, I would like to begin the session for today. Over to you.
Thank you very much once again, and I think you have to be bored by me for the next at least half an hour. And my apologies for trying to keep on pushing this angle about how well China has done in the space domain. So today I'm going to talk a little bit about the space part of what I think they'll do. Everybody see it? It's readable? Yeah. So, I mean, I've tried to make the font big, but sometimes it gets a little smaller because you always have more to say than what you can show. The problem with all academics is they keep talking and talking and talking. They don't do anything. So I will talk a little bit about what the space part of China's anti-access area denial strategy. In the morning, in the introduction, I told you about our interest in the fact that, this anti-ship ballistic missile, now that has to target a lot of aircraft carriers or any other naval asset that is approaching Taiwan from all the seas that are surrounding. I'll show you a picture so that you get a better idea of the geography. Obviously, you have to locate something in a very large area. The ocean is a huge area. A ship is a relative, even an aircraft carrier with all its assortment of accompanying quite distributed. It's kind of difficult to locate. It's like locating a needle in a haystack thing. And therefore, one of the problems in you have to be able to locate it. And not only must you be able to locate it, you must be able to keep track of where it is, because the problem of any conflict arising is a dynamic kind of thing. So while there are certain predictors about when it can happen, you really don't know whether it will happen or not, and therefore you need to keep tabs on the particular target that you have in mind. So these are the two kinds of problems that a typical anti-access area strategy needs to address. And I will talk about how China has kind of over the years created a very robust capability, and I will present some details about how they could be doing it. Okay, so that's really the kind of thing that I want to focus on today. And please feel free to interrupt and ask anything that you feel is important. I mean, if there's any doubt that you have, we can clarify. And of course, I hope, have a big question and answer session where we. Okay. Can I have the first slide, please? Yeah. Now, we all know what happened in August 2nd, 3rd, 4th, 5th, I mean the first week. We had all this major confrontation over Taiwan. I think Nancy Pelosi visited Taiwan and the Chinese wanted to make a point. And therefore, they did a lot of things. They carried out a lot of exercises and maneuvers. This is a very well, what I call, thought out a picture that was put out by CSIS, right, in a journal called China Pa, and it tells you where all the exercises areas were, where the Chinese actually conducted military exercises, and you can see that it is surrounding all of Taiwan, and it is also looking at all the major military targets. The air bases are covered, the naval bases and the ports are covered. And some of the exercises are also covered in areas which are called disputed areas. They're disputed areas of the EEZ, for example. So the Chinese are making a very clear demonstration of what they can do. They want to show all the neighboring countries as well as the US, this is what we can do. Okay, so it's like they are projecting their ability to respond to a crisis over Taiwan. Okay, so that's really what they're trying to do. And if you see the dotted line, now in 1995-96, there was a similar confrontation between China and the United States. And in that confrontation, what happened was they fired some missiles, but that was largely along those two islands called the Matsu Islands and the Kinmen Islands. And you can see the dotted line where we talk about one. That was the extent of what they could actually do at that time. Okay. Now, since that time, you can see that they are now able to precisely do all kinds of exercises, integrated exercises, around the whole of Taiwan, and it covers almost all the sensitive military installations that Taiwan has in mind. So it does mean that between 95 and 96, when the third Taiwan crisis happened, and 2022, when the fourth Taiwan crisis happened, they have moved forward significantly. Now, if you go back in history, I mean, some of you might want to look at that also. There was a Korean crisis, a crisis in the Korean Peninsula in the 50s, where the Korean War was fought. At that time, Taiwan was also in the middle of a lot of the issues, right? And then there was a second Taiwan crisis and first Taiwan crisis and a second Taiwan crisis again in the late 50s, where once again the US prevailed by sending 2 aircraft carriers or a few aircraft carriers to that part of the ocean. The same thing happened in 1995-96. So one of the reasons why the Chinese are paranoid about the anti-ship ballistic missile and making it happen is because they are always worried that the projection of naval power, historically naval power, has created a lot of problems for China, and it continues to do. So in a sense, you can argue that the entire response of the PRC and the PLA is about responding to this naval threat. Can I have the next slide, please? Yeah. Now, apart from the exercises, there were also a number of ballistic missile launches that they kind of put out. And these are some of the targets that they are looking at. And there are a number of locations, mobile locations. They can move around most of these things from where they can launch. And it can come from all kinds of directions, making it difficult to defend against. Okay, so all these things are there, and you can see that once again they have targeted quite a lot of the areas in around Taiwan. Okay, so not only do they do the exercises, but they also have this precision strike capability that enables them to pick out a ship or something on the sea to be able to hit it. So this is the other thing that that was quite clear from the exercises carried out. So the next slide, please. Yeah. Now, I had made an earlier presentation to C3S, right? And I had looked at the vulnerabilities of China. So why is China so paranoid about all this? And why is it actually creating all these capabilities? Obviously, it has concerns, and most of these concerns are about its neighborhood. So China has got about 14 land boundaries with different countries. And this just tells you the kind of problems that they have. So you have Russia, North Korea, Cambodia, what I would call the Korean Peninsula, the Indochina Peninsula. You're looking at India, you're looking at the Central Asia, and of course you're looking at the earlier enemy, now turned friend, Russia, or the Soviet Union earlier. So you have, these are the kinds of threats that it is facing on its land. And of course, what happened in the 90s when the Soviet Union broke up is that the major threat that they thought was from the Soviet Union had actually now become a little bit more comfortable for them. And you can therefore look at a ranking of all these vulnerabilities from the basis of this. I've just put down one ranking that I think was the right ranking. You could come up with other ways of doing it. So this is the land side of China's vulnerability. Have the next slide, please. But you must also remember that China has a lot of ocean areas, and a lot of the threats in the last 150 years have always come from the sea, especially from the British, US, Japan, imperial navies, and the 100 years of humiliation that China went through. All of it has a significant naval domination by the Western countries. Okay. And one would therefore argue, and Taiwan, seceded in a sense from what the PRC thinks is its own country when the People's Republic was formed in 1949. So you therefore feel, so you can actually look at the threats that from the sea, which seem to be the major threats. So Taiwan is obviously the number one threat, and that is one. Korean Peninsula is number two, close to number two. There's a war that fought. The Indochina Peninsula, including Vietnam, there's another war which China fought with Vietnam, so that's also another major area of concern. The US base at Guam is not too far away. So you can actually see that these are the kinds of threats, and the threat from the sea is significantly greater than the threat from the land, is the way I would look at the way we have to look at all of that. So we can now look at a kind of combined land and sea based kind of thing that China has to contend with. Can I have the next slide, please? So one could therefore rank the threats in some form. Taiwan is obviously the most important part, and the Chinese think it is a part of them. There is a historical basis, though Taiwan has been with China only for about 300 or 400 years. Guam, the US base, is a major problem because it has a large, military base. Japan has always been a threat. If you go back and look at the history of China, Japan and Chinese problems have been a major role in the 100 years of humiliation that China went through. The Korean Peninsula, China has dominated it. The Korean Peninsula has kind of reacted. So it's also another Indochina, Vietnam. So these represent, in my opinion, the major threats. And as you can see, most of the threats have a significant naval or a sea component. And therefore, the Navy and the sea part of China's anti-access area denial strategy is kind of important. So the threats are likely to come largely from the sea. Therefore, you have to make sure that you can deal with these threats in the proper way. This is really the background within which we need to look at the A2AD strategy that I'm talking about. Can I go to the next slide, please? Okay, I'm sure all of you know the first island chain, right? This is the immediate threat in the immediate part of China's neighborhood, and obviously it doesn't want anybody coming into this island chain. And then you have what is called the second island chain, which also encompasses the US base at Guam. You want to make sure that in this area also, you don't want any hostile forces. So ideally, you would want any hostile force to be dealt with outside these two island chains. So you want to target things that are far away. You can see relatively by these distances, you want to target things that are far away from the coastline of China. And obviously, if you want to target and identify objects beyond that coastline, you need to be able to look over the horizon. And if you want to be able to look over the horizon in a foolproof manner, you need a significant number of satellites, okay? And that is the reason why satellites and space has become very important as a part of this A2AD strategy for the PRC, okay? Now the next slide, please. And how do they reach these targets? Now, obviously, one way is to have an aircraft carrier that can go all over the place and project the air power through the aircraft carrier. Chinese don't have that many aircraft carriers. The Pacific Ocean is very big, and it may take a long time for them to be able to do that. The other alternative to replace an aircraft with a precision strike missile, and you can see that the Chinese have a whole range of missiles which are dedicated to this, okay? And increasingly, these missiles are becoming more and more accurate, so they can actually precisely hit target, okay? And in order to be able to precisely hit the target, they also have to know roughly where the target is located. So there's a lot of autonomous capability in these missiles, and once they know the broad area or a limited area within which they can look for the target, it can go search for the target and actually hit the target. Those are the kinds of capabilities that we can actually do. Now, originally, when you look at the missile mix, a large number of them were nuclear focused. But today, I think the significant number of missiles are conventional missiles. They are either ballistic missiles or cruise missiles. So they operate functionally differently, and the combination can be very lethal, okay? So both have advantages, and some of them have a few disadvantages. But in combination, they can provide a lethal force. And as the precision accuracy increases, they will be able to target more and more accurately, right? So an aircraft carrier is a very large vessel, okay? Can be identified fairly easily. And once you know where it is, it can also be hit fairly easily, okay? So that's the kind of thing that we are talking about, okay? The conventional missiles are now the dominant thing. They are the fastest growing part of the missile arsenal. So while the nuclear missiles are also getting modernized, the relative pace of modernization and improvements is more on the conventional side and less on the nuclear side, because once you have a nuclear deterrence, it doesn't really matter how many numbers you have, although China is also increasing those. Can I have the next slide, please? The other part is, do you have the organizational capability to be able to carry out those exercises? Uh, so in 2015, China decided that it would break away from the conventional organization of the military in terms of the army, the navy, right, the air force, and also they had a special artillery force that looked at the missile part. And they decided that rather than looking at it in terms of the functionality, they would go with theaters. So they established 5 theaters: the Eastern Theater, Southern, Western, Northern, and Central theaters. And therefore, the theater guys, the theater commander, became the paramount, what I call, authority for war fighting in that particular theater, right? So the army, the navy, and the air force, and the rocket force, and other part of it all had to come under the purview of the theater command, in a sense. Okay? Now this involves a significant reorganization of the military, and it's not easy to bring about some of these organizational changes. So that was one major thing that the PRC created under G, of course. And they also created this other thing called the Strategic Support Force, if you look at the top, which dealt with the space part, which is like a common requirement for all theaters. And there's also this information requirement. Space is a part of the information requirement, because collecting the information through surveillance satellites, also moving it around through all kinds of satellites at medium, low Earth, and geosynchronous orbit, as well as, in my opinion, the cyber part, because satellites use a number of microprocessors, and a lot of it is data based and control based data, digital data control. So once again, all of that is very important for war fighting, and so they created this special force called the Strategic Support Force that kind of gives them the organizational tools along with the theaters to kind of fight and win, right? I talked about it earlier, local wars under conditions of informationalization, which is what they see. So they see a Taiwan crisis as a local war. That's really the perspective with which they are looking at. Now the next slide, please. This is just to give you an idea of the theater commands. I think everybody must have seen this slide. I'm sure a lot of you have studied it. Can I go to the next one, please? So the point is, all this part therefore reveals that China has not only taken the necessary steps and to do all this. So how does the space part of what they're doing play a role in this anti-access area denial strategy? I think as of 2020, when this book had kind of finished, China had what's called 68 Yagon satellites, okay? And about 40 of them were operational. About 20 of them had kind of finished their life and were kind of not in functioning order. And most of them are dedicated for what I would call the intelligence, surveillance, and reconnaissance function. Okay. Now, basically, what does it mean? It means that they collect data. They try to locate objects within that thing. So this is mainly what I would call a remote sensing satellite, or imaging satellite, or a synthetic aperture satellite. Or if they collect electronic intelligence, they are electronic intelligence satellites. Okay. And so what we did at NIAS was to look at all of them and then try to categorize them. There's a whole lot of approaches that we can do to categorize them, and they are fairly easy to do. They're not very difficult to identify. And we can actually, from the way the orbits are, the kind of perigee, apogee, the altitude, the launch vehicle, the mass of the satellite, we can make and that what I would call the launch time, we can come up with a number of open source parameters by means of which we can actually fix, okay, the kind of satellite that a particular Yagon satellite associated. And our work at NIA showed there are 2 types of electronic intelligence. They also have 2 types of electro-optical sensors, and they have a synthetic aperture radar capability. And so what can they do with this constellation? So for example, you want to look at a particular point on the Earth, for example, Taiwan during the crisis, we can actually select these satellites, right? Understand their functioning, and then be able to find out from them, right, what part of the time looking at, would a target like Taiwan be covered by, right? So this exercise is something that it was possible to do, and we did it because we had a special software package that was developed by my colleague Dr. Ramani. Okay, and I will tell you a little bit about the results of this exercise. But before that, I have to tell you a little bit about the nature of the satellites and the kind of coverage. Can I have the next slide, please? Okay, now as I said, when we were doing the ASBM, when the problem of the anti-ship ballistic missile was first referred to us, we wanted to know whether the Chinese could actually locate an emitter, electronic emission source, in the Pacific Ocean. Now, the first of the requirement to do that is what is called the Argon triplets kind of satellite. So this is a 3-satellite constellation that is in a triangular that flies in a triangular formation. The distance between the 3 satellites is very well known. Okay, they put the satellite in a very special kind of inclination, 63.4 degrees, and that inclination is chosen for a particular purpose. A satellite in a 63.4 degree inclination will not precess at all. What does it mean? It means that the satellite perigee and the apogee, which are the 2 extreme points of the satellite, are likely to rotate time. If you put it in a 63.4 degree orbit, it means that they will not rotate at all. The rotation, the precision rate, and the Earth's precision rate and the impact of the orbit itself will make sure that the perigee and the apogee will always be at the same fixed location in the orbital plane. Okay, so this is it. So if you have 3 satellites and the position between them is known precisely, those positions are not likely to change. You put it in this kind of an orbit. The practical implication is that. Okay, so if you see 3 satellites put together in orbit in a 63.4 degree inclination, you have a dead giveaway that this is a electronic intelligence triplet, right? And what does the triplet do? If you have an aircraft carrier that is emitting radio signals in the Pacific Ocean, it can locate it within a certain range, say 25 kilometer CEP or a circular error problem. So it can locate it. So instead of looking at some 7,000, 11,000 kilometers, you can narrow down to about 25 kilometer radius circle, right? Which is a significant advantage. You don't have to look at the whole of the Pacific Ocean. You can look at the part that you think where the particular object or target. So that is the advantage of this kind of orbit. Okay. So we did this exercise, and currently China has this, they are calling them the Argon 31 series. They have 12 of these satellites. So they have 12 operational satellites. They are distributed in different planes. I'll talk to you a little bit about that. So this is one of the requirements. So you see that small blue circle on the right. So within that larger circle, I can locate a particular emitter to a smaller degree of uncertainty. It's very, I can locate it fairly okay, right? To enable me to target it a little bit better, right? That's the purpose of this. Can I have the next slide, please? Now, that by itself is not enough because you don't get continuous coverage, right? And what happens, why do you need continuous coverage? If it's far off, beyond the second island chain, I don't need to track it so often. But as it comes closer to my shoreline, right, I need to keep tabs on it much and much more, right? I need to know where it is continuously. In order to do that, they launched a second series of electronic intelligence satellites. Now, those are not in the triangular formation. They are all in the same orbital plane. I will show you the geometry a little bit. So these are at different inclinations. They are at 35 degrees inclination. And they are orbiting at about 610 kilometers. Okay? And they have 18 satellites in this configuration. And the coverage circle is about 10,500. Right? Here, you don't know the location of the emitter. But if you know the location of the emitter from the earlier satellite, then you can locate this emitter also within this larger circle. So this is the kind of logic that they are building. So the 12 satellites that they have earlier and the 18 satellites that they have now together will be able to continuously keep track, right, about the emission of any radio things that are happening in the vast reaches of the Pacific Ocean. We understand that? Is it clear? Yeah. Okay. Can I have the next slide, please? Yeah. Now, just to give you an idea of the tactical thing, so the Earth you can see is got 360 degrees. What you have is, you have three different planes, orbital. Satellite is going over Earth. If I am at 0 degrees, one constellation at 0 degrees longitude. The constellation is going at 120. When the Earth rotates, so when the Earth rotates, right? So one satellite series is going to be seeing a particular target. As the Earth rotates, the next plane will come and the next series of satellites will see the target. And then there's a third plane that will rotate after the Earth rotates even further. And after the Earth rotates a little further, the first plane will come back. So you have these planes that are different locations that cross the equator at different. So you can see that one location is 120 degrees, separated by another 120, the third 120. So 360 degrees, you can have three planes of orbits. Each plane there are 6 satellites. Together they make 18 satellites. And as the Earth rotates, one plane is replaced by another plane is replaced by a. And along with the triplets that I talked about, they will enable us to keep universe tabs in the Pacific Ocean. So this is the logic or the architecture of the Argon satellites. And so there are a total of 18 satellites. And I think the last data I have is they are not even 3 planes, they are something like 4 or 5 planes. So they're kind of optimized it. One has to do more detailed studies. So so you can actually see the separation across the globe. So and as the Earth rotates, one plane will go, another plane will come. They will continuously be able to track the target. Have the next slide, please. Okay, just to give you the idea of the geometry, in each plane there are 6 satellites, and you can see they are separated by 60. As one satellite goes over the horizon, the other satellite will rise, and it will. So 6 satellites in sequence cover the area, one after the other. And as the Earth rotates, the next plane, which also has 6 satellites, then take over. So this is how it works. Just to give you an idea that this is the geometry of the architecture that they're. Can I have the next slide? And along with this, they also have these imaging satellites. They have 2 types of satellites. One are in 1200 kilometer orbit, which gives them about 1000 kilometer. Now, optical sensors can be moved. They have a field of view which is about 60 kilometers. But because you can move the camera, it will actually cover 1000 kilometers. So if you know an object to be located somewhere within that 1000 kilometers, I can actually more precisely get a picture. Once I get a picture, I can locate the object, accuracy of a few meters. So from kilometers with an optical imaging satellite, I can reduce the inaccuracy significantly. So that is the purpose of the optical imaging satellite. So they are in 2 orbits, and one is in 600 kilometers sun synchronous orbit, the other is in 1200 kilometers sun synchronous orbit. These can again be identified using the standard stuff that I talked about. You can categorize all of them, and we can derive these things fairly easily. Have the next slide, please. Okay, now SAR satellites are slightly more complicated. Our SAR satellite can look only at one side, okay, which means that if the satellite is going like this, it can look at this side, it cannot look at this side. If it looks at this side, it cannot look at this side, okay? And the area beneath the satellite thing itself, it cannot see. It can only see a stretch to the side of the satellite. So the modeling of the sensor is a little more complicated. So this just to tell you that this also has to be kind of captured in the analysis that we. And so you can actually the 1000 kilometers directly below it may not be seen. You will have to move it around that, and that's the kind of swath that we can get. So we have all the details of all. So all this stuff that you are talking about, the sensor parameters are based upon publicly known information. And a lot of it is publicly known. We all know this. Many of us have been involved in a lot of it. So I think there is a reasonable accuracy with which we can model the sensors on these Argon satellites. So can we go to the next slide? Okay, now I have to tell you a little bit about the software. Now my colleague Ramani developed this software called the Veni Vedi Vici software, right? And we can therefore take stock. I told you Taiwan. we can actually find out the coverage of Taiwan during the crisis by using this constellation of satellites. The software enables us to do that. Now, how does it work? It uses the orbital information that NORAD, the North American Air Defense Command, they put out these things on all satellites. All the Argon satellites, the data is available. What Romani's software does is it takes the data, and we can then look at the orbit, how the orbit will move for the next few days. And we can actually make a prediction as to where the satellite will be at what time. So that part is, so this is fairly easy, and Romney has been dealing with it in ISRO for a long time. But we had to do some changes. He will, if required, we can talk about it. Okay, right, so this is one part. The other part that this package does is, we also model the sensor that the satellite will carry. As I said, from the orbital data, we can find out what kind of a satellite it is, and we can know the sensor, right? I showed you the coverage of those sensors, the ELINT sensor, the triangular ELINT sensor. I showed you the optical imaging, the SAR imaging. I showed you the architecture. If you put all of that together, right, we can actually get a good idea of the coverage. So what we can also do is, you can specify any part on the world, right? Any target. It can be a point target or an area target, and we can find out how much coverage of that is obtained through this satellite constellation that we have taken. So we will look at a problem that is looking at Taiwan between August 4th and August 5th, for it. And in our run that I'm going to show you, we have only used the 12 broad area ELINT satellites, which give you the location information, and the 18 tactical ELINT satellites that keep tabs on the constellation. And we will look at the results of this study in the next. Can I have the next? So now what we did is, we looked at Taiwan for a period of 24 hours, between August 4th at 4 hours to August 5th, right? 0 hours, sorry, 12 midnight to 12 midnight. And so we can see that, so the first is the satellite. The first column is the satellite number that we are talking about. The second time is from the start of the simulation or the projection, how much time has elapsed. And the second column tells you how much time the target is covered. So the first Yargon 30Z, within the first 3 seconds of the start of our exercise, the target has been observed for 2 minutes. That means 2 out of 3 times it has been 2/3 efficiency it has achieved in the first 3 minutes. So if you go to the 4th minute, it has shown 3 minutes. So the efficiency increases to about 75%, right? So you do that. So if you look at a number like 101 minutes elapsed time, you get the coverage time of 83 minutes, and the efficiency is about 82.17. Right? And as you can see, within a very short time of about 2 hours or 3 hours, we get to an efficiency of about 88%. So the number comes to about, so in other words, a target is visible for about 90% of the time, 88% of the time over this period. So this is something that I think very useful. Now the other part we can do is, we can also get the details about how much time there is a gap, right? If the gap periods are very long, then we have a problem. But if the gap periods are going to be less than a few minutes, right, we have no problem. Because within that, the target could not have moved. It will be approximately the same. So these are some of the things that we can actually do with this kind of approach. All ships, any ship. The stealth ship does not emit electronic, any electronic emission. If you shut down the electronic emissions of an aircraft carrier, I'm not sure it's functional. Effectively, you shut it off. Without emissions, it cannot survive. I mean, it cannot do its job. I don't think survive is the right. In other words, yeah, we can do all that. But without emission, aircraft carrier cannot do it. All of that is there. I do, all of it is action. All of it is possible. So what I would like to argue is all of these possibilities and the action-reaction approaches that one can take have to have a baseline on which you can play all these scenarios. I would argue that this is the baseline on which we must impose all those conditions. Then look at how do you do those conditions. In other words, the first step in a game playing exercise. But this is the first step. I mean, you can question the value of the first step, but without this first step, you can't even go to the second. You can't even think about this. So I don't want to go into tactics. I'm not an expert in all. But I definitely know that if you don't have this baseline, you can't really look at any kind of approach to dealing with it. I mean, that's really the point I want. So I think all those things, countermeasures, non-countermeasures, so what I would call action, reaction, action, reaction, action, go to 5, 6 order, 7 order, you can go on playing these games. The argument is you need to start somewhere, and the first step that you need to know. So frequency hopping is certainly a possibility. Standard. Encryption is another possibility. There are other things, spread spectrum. So there's a whole lot of. Okay, can I have the next slide, please? So I just show you the typical run for the whole day, and you can see we have efficiencies of the order of 88 or 89%. But more than that, we have to worry also about the gap. If the gaps are not too large, I would say less than 5 or 6 minutes. So we did an exercise to gap, although I don't have the data here, but it looks like the gaps are very minimal. Most of them are between 5 and 8 minutes. So one would argue that it's not only that 88 or 89% efficiency, it is very difficult for an emitting target to lose. The Chinese will be able to keep tabs on any emission, right, that is coming in accessing towards type. Okay, that is the conclusion that I can say. Now, in this exercise, I've not included the coverage of the optical and the SAR satellites. The moment that comes, the location accuracy will become much better. So the next exercise we will do is to bring that in also and get a better number. So we need to look at the distribution of the gaps. We also need to look at bringing in those satellites, then looking at them. But it will be very difficult, according to me, to escape surveillance by the Chinese satellites. Okay, I think this is pretty clear from the architecture. So the Chinese are just not talking, they are actually demonstrating it. It's been operational now. I would argue more than 5 years they have this complement. And they are likely to keep changing it a little bit. We need to understand those changes. That is, right, can I have the next slide, please? So how does it work? Just to recap, the large area ELINT can locate the emission source within an area, say 25 kilometers CEP. This is a number I'm not sure about, just a number I put, okay? But it will help. We need to do a little bit more technical work. We are not equipped to do it. We can actually get a better handle on location with some expert. But I don't think we can do it with the resources we have at NIAS. We cannot do it. This will help locate the same emitter by the tactical ELINT, and it can keep tabs on it. If the area falls within an optical or a SAR sensor, then its location will be determined with an accuracy which is of the order of a few meters. You can determine it much more precisely. We have also looked at the gaps in coverage. The results show that the gaps are mostly of the order of a few minutes. So it's more or less continuous. Okay? It therefore appears that the right kind of queuing, the movement of a ship can be continuously tracked. The information transmission to various entities may also involve communication satellites in GSO, and they are tracking and data relay satellites also in GSO. Both of them, China has them, and they will use them. It has also helped, right? There are a number of other elements that have to work together in order to make this strategy real. It's not only about satellites. You need submarines, you need frigates, you need all the Navy, you need drones, you need aircraft carriers, you need the army maybe in some locations, right? You need air force of various kinds. You need missiles of different ranges, different platforms from which you can launch them. So it's a whole complex array of all kinds of integrated components that have to be put together. This does not address them. We have to look at them separately. I have another study that I've done, which I will not talk about here, but we can actually build on that and kind of do more detailed, integrated kind of approach to what what approach should be. Can I have the next one, please? So I would come back to the slide I showed earlier. I think China has in place all the space components that it requires. They have one thing that is not missing. They have what's called an early warning satellite, which is a geostationary orbit that can pick up the launch. Now, I think from the data that I've seen in 2019 and 2020, more or less one can argue that they are experimenting with that. I would expect that that gap will also be soon filled. I think they have it, but it may not yet be operational. Red. And so they have something like a, what I call, they call it a staring camera, which means that it is it's looking at a part of the world, and anything that goes about 10 kilometers that has a temperature signature can be. And if they can track it a little bit, they can actually predict where it's. That's what the Americans have had for a very long time. So I think they are there also, but we are not sure yet. I would argue from whatever data I've seen, that is there. Of course, as I pointed out, they are putting all of this together. There's an integration organization in place that takes care of all of it. Operations command, all of this, all these components that they have in place. So this part, I tend to believe the space part and its correct connection with the access denial is very much clear and evident in the Chinese space program. Can I have the next slide, please? So just to come back to, so the Chinese are looking at space as a part of a larger power projection. So the civilian use and the military use are well connected, and there is an increasing integration between the civilian and the military function. So if the military has a problem, there's a backup civilian option available, and the Chinese are kind of strengthening these connections. They have an arsenal of missiles, as I pointed out. They have a very strong economic agenda. Just to give you a point from the book, they have sold, see, the Americans put an embargo against China, which prevented any satellite launching by China, which meant that if any satellite carries an American component, the US State Department will not give a license. Okay? Which meant that the satellite, if it was to fly on a Chinese launcher, would not be allowed to fly. Now, the Chinese have lost quite a lot of launch opportunities because of that. So their workaround plan was to completely indigenize the production of satellites without any American component. Okay? So they went and collaborated with a number of European companies, and they've come up with a number of satellites which they have used domestically, which they produce domestically. And now what they do is, instead of buying a launch, you buy the delivery of a Chinese-built satellite in geostationary. So it's kind of bypasses. And most of those satellites do not have any American parts. Therefore, sanctions work. At least that's what I think. This is, so the Chinese have exported satellites to Nigeria, Pakistan, I think Bolivia, number of countries, all of them are listed, Laos, Belarus, okay. So they have about 13 satellites. Saudi Arabia also, I think, or they have kind of built, and the remote sensing satellites also they are building and delivering. So they are taking care of that. So there's also the economic agenda. Then of course, coming back to this part I talked about. So in the conventional war, right? In the earlier days, we looked at nuclear weapons and conventional weapons. We now have to go beyond that. We have to not only look at nuclear weapons and conventional weapons, we also have to look at space and space-related weapons. We have to look at cyber-related weapons. And the platforms can be land, sea, air, underwater, right? I don't know, the intermediate region between space and the atmosphere. A whole lot of dimensions are changing. Of course, the geography is now the world, and geography is also going to be a part. So it's going to be a different domain and a different kind of thing. And so as I pointed out in the last presentation, right, the US domination of the IT battle space, the only counter that the world has to offer today is China. And therefore, this new dynamic between the US and China is actually going to drive a lot of what's going to happen, not only on the military side, but definitely on the space part. Any more slides left? Let's check. Over. So the point I want to make is that the A2AD, the space part of A2AD, is operational. And in my opinion, it's a significant enhancement Chinese military powers for engagements in the ocean areas of the world. Okay. But I would argue that China is not really interested in all of the ocean. It is more interested in the Indo-Pacific part of the ocean. And in that area, I tend to believe they have become very strong since the earlier Taiwan crisis. And I think that strength is likely to continue to grow. And the US, unfortunately, is a global power, so its resources are distributed across the world. And I think concentration of Chinese power in this part of the world will definitely stretch, right, US resources, right? And it's also going to result in a significant economic cost to the US. Which the economic cost to the US is much more than to China, for example. So it's going to be a different kind of problem, right? I think the US systems are engaged with it and they have different approaches to looking at it. But one part of the US strategy in this part of the world has to be an alliance-based approach, right? So the allies are going to become extremely crucial in this fight for the Indo-Pacific part of domination. I would like to end here, and any questions, welcome. I can stand. I don't used to like. What will be soon?
So this is Bala from C3S. Thank you for the insightful presentation. I have two questions. One is regarding the Beito, the NavSat system of China. So correct me if I'm wrong, they have a unique system where, it has a SMS provision. So can we infer that China now can influence operations through SMS? Why do you think now it is being provided? Point number one. Just 1 second, I'll just go for the second question. And when reading through the literature, what I got to know is that China is very much interested in the pulsar X-ray based navigation system. So why is China is very much showing interest in this? Thank you, sir.
Okay, so let me answer see, once you have a communication capability, use it in any form you want. What does it matter? SMS, any other form you want. I think the bulk of the problem I think we should move away from. See, we see communication satellites as one important resource, right? US doesn't see it like that, for example. You can do practically anything that you do, right, with the US communication satellite, especially for military operations. The guy at the field can get almost anything he wants. And that is simply because the capacity of the communication satellite system they have, both the commercial side and the military side, right, is available, and it's robust. Irrespective of what happens in the link, right, they are worried about how to get it to the guy in the field, right? I don't know whether you've seen the drone operations and all that, or the Osama bin Laden operation. You can see that they are actually connected to anything that happens anywhere in the world. It's simply because of the satellite system. So Viasat, their communication satellite, which I think has a throughput of, I remember reading 100 gigabits or something. The Chinese are about 20, and we are at about 10 or 15. So the point I'm making is satellite communication capacity that carries the information from the sensor, right? You're sensing something. You want to make sure that it reaches all the people. So in other words, you want to take the data and process it through the entire network so that whoever wants to get it is able to get it. So we should think of the communication as an essential part, right? And maybe the more important part of an information. So you are looking at it purely SMS. What is SMS? What is anything? Either a map, terrain map, a location map, or you want to know where the enemy things are located in real time or near real time. It takes a few microseconds to go and come down. It should be available to the guy on the field. My argument, the Chinese are thinking. So they have only 9 dedicated military satellites. Okay? Communication. They have 4 TDRS satellites. 5 now. So they have at least 14 or 15 dedicated communication satellites. They have a fairly big civilian capacity. So some of this traffic can also go through the civilian thing. So what is SMS? Anything else, anything that you want should be available. That should be the motto. They're always looking at satellite communication, the constraint. They're talking of one side. I think we should have 20 communication satellites dedicated to them. Why can't we do it? We can do it. We should think differently. My point is, in an information war, if you don't have the ability to move around information, you are lost. Right? It doesn't have to do with the bravery of our army and navy. It's fundamental technical capability that is minimal in a war, in a modern war. We must do it. So this is the first one. So the reason why the Chinese are interested in a pulsar thing, there are two reasons. See, one is the purely scientific, what shall we say, accolade that you get because you're the first in the world to do something. Now, the Chinese are particularly interested in the political mileage that they get out of their space activity. So I would argue that all the planetary exploration program, the moon missions, right, what I call the famous what I call quantum satellite, all of that are kind of first. The Chinese want to tick that box because it does definitely give them major political advantage. So that is one. Second part, which is actually very functional. Pulsars time, the rotation rate and the timing of the signals is very, very precise. So if you have a number of pulsars and you have the timing information associated, it's like a natural made atomic clock. Okay? So you can use that time. See, here you have GPS on the ground, but if you go into, I don't know, moon or interstellar space, right, you need another timing device, right? It's possible that you can use it even on the Earth. So maybe it's an alternative to the GPS. They are looking at it. So the other part, in my opinion, function. Gives you very precise time information, which we can use for navigation. Both of them. So it's got an applied purpose, it's got a political.
Sir, my name is Vivek. I am from Defense and Strategic Studies University of Madras. Sir, my question is that A2AD strategy of China. US started US launched a counter operations for it. It is known as EABO, Advanced Base Operation. According to your gap, I mean the satellite vision gap is very minimum, that it is 5 to 6 minutes. So how come US can successful in this operation, especially China Sea? It is focused on South China Sea. How can it be? I mean, there are any loops to maintain his counter it?
So let me come back to this question, right? So what is the problem? One of the problems is going to be how far can you come into, right, the seas of China. So I talked about the first island chain and the second island chain. Now, one of the problems that the US had earlier, right, was that they had signed a treaty called the Intermediate, Intermediate Nuclear Weapon, all the intermediate range missiles, right, were not to be developed either by the US or by Russia. Okay, so I think missiles in the range of 500 to 5,000 kilometers were taken out of the US arsenal. Okay, now what has China done? All the things we are talking about, they are either short range, 200, 300 kilometers, or you are looking at the maximum 3,000, 4,000 kilometers range, right? They all come in this INF treaty limits. Now, what the US could do, right? There are two things that the US is talking about. They have a concept called air-sea battle. Right? What does that mean? It means that they want to dominate. The US has never fought a war in which it has not dominated. So what they want to do is to dominate the space within the first island chain, within the second island chain. And in order to do that, they need a significant aircraft capability. Right? They also need a significant enhancement of their navy. There's a lot of stuff that people are writing about. Okay? The point you want to make is all these options. So if they have to develop a new generation stealth fighter, for example, which can counter the Chinese air defenses, right? It's going to be.
They're also focusing on LRU, under surface vehicles.
Yeah. So the other.
Yeah.
So let me come to that. So one part has to do with the development of new capabilities. to develop such a aircraft, for example, that can penetrate the protection that the PRC is now creating, right? It's got a very strong conventional, SAM-based, or what I call missile aircraft-based defense layer. To fight a defense war, they are very strong around Taiwan. Very strong within the first island chain, pretty strong within the second island chain, right? Beyond that, they are not that strong, right? Now the approach that the Americans should use is to try not to come within these, but to do it from a distance, right? For that, they have to abrogate the INF treaty, which they have not. So they're going to change. But this notion that we will dominate the battle space means that they have to significantly add to their current strength, both as far as the aircraft are concerned, which are very expensive, and also don't forget, submarines are also extremely expensive, okay? And it's therefore going to stretch a lot of the military resources of the US also. So this domination strategy that the US is following, see, the other part you must remember is the US is a global power. China is not aspiring as of now to do the globe. It is only worried about protecting this part. So if it invades Taiwan tomorrow, it wants to make sure that the US doesn't intervene in a few days. If it's able to do that, it will take over Taiwan. Okay. So the problem really is, for the US, the problem much more complicated, because it has to move resources around the world. From all over the world, it has to come. It has to group together. Before, for example, Iraq, it took 2 or 3 weeks for them to get their act together before they could move it. It's not very different. Geography is still there. In spite of all this IT and all, physical movement of, of platforms and weapons have to happen. It's not completely cyber, or everything is completely gone. So the point you really want to make is, it's going to be difficult for the US. Whereas if it has allies in this part of the world, then there's, just as China has an A2AD, the allies can also have their own A2AD, right? A lot of them are islands. We can do the same thing that China is doing, right? And that way we can actually deter China. So what I'm arguing is, there's a whole range of strategic choices that is opening up. And the renunciation of the INF treaty means that the US is also going to respond, maybe not necessarily in the way of dominating the entire first and second island, which has always been their approach. Maybe that is not going to work so well with the Chinese case. That's how I would look at it.
Russia is trying for this A2AD capability.
I would argue Russia is a very formidable space power, okay? But it is not, shall we say, I would argue it's on the decline a little bit from the last few years. Russia and China will work together. I think that part, now they don't like to work with each other, they don't like each other, but because they have a common enemy in the US, I tend to believe that alliance is going to be stronger. I think the next 10 years we'll see a closer relationship. It's difficult to predict beyond that. Politics is evolving, changing, geographies are changing. So I would argue that, yeah, the Russia and China nexus, if you look at this region, there are a few countries. Pakistan is one. I think Cambodia may be another country. So the Chinese, what I call, ability to have allies in this region is much less than the US. And of course, countries like India, we will have to be neutral in a sense, but definitely with the US tilt. But we have to do our own thing. We cannot depend too much on the US, because tomorrow Pakistan may become important. They will completely ditch us, like it has happened in the past. So we should be smart. We should ally ourselves with the US if required on many things. Definitely China is a greater enemy for us. US is definitely a friend. I mean, those long-term things are not wrong. But we have a number of choices to make, and it's kind of difficult to navigate these choices. I tend to believe our interests are more with the Western alliance, although not totally. Definitely we should be seriously worried not only about the military threat of China, there's a significant economic threat. They can disrupt our economy quite easily. So we have to look at it in a broader context.
And I'm from the Department of Medicine. Sir, my question was China's but apart from that space station, the Taiwan what they bring challenges to, because when it comes to our ISRO, and, what are the challenges?
Okay, so let me deal with the space station. See, I come back. All manned space missions are political. What shall we say? Political projections of great power status. Okay, whether you're great power or not, I don't know. But projecting a manned mission means that you have entered this respectable, powerful nation category. Okay. So the logic of the manned program for China has always been, ever since the beginning, the political part of becoming a space power. Okay, so they have never hidden it behind any agenda. They've always said that's what we want to do since Mao's time. My book, all of that is kind of recounted. You can see there's a whole history. And only when they had the capability and the money, they actually ventured into it. And once they ventured into it, they become pretty successful. So now they are looking at using this political goodwill to make an impact on the whole world. So they are offering the space station, for example, for every country in the world to put up facilities and to do research on that. So they have tied up with the United Nations and they are actually taking this offer globally. So on that part also they are fairly clear. So all the interplanetary missions, now there is also a possibility that space mining, right, mining the moon, mining the planets and the asteroids can take off. I would argue maybe 20, 30 years from now, these things may be possible. Definitely 20 years at least it will take to get to it. And there's a whole lot of legal and international issues that it could raise. Of course, international issues don't matter because if you have the power to do it, you will do it and nobody can stop you. And that's exactly what the World International Space Order I talked about is all about. So UN is not a forum where these things will be negotiated. If you want to be at the high table, you have to be a powerful player. So that's the part about China. China has to be on the table in any negotiations, whether it is on military space or weaponization and also on the economic agenda of space. Okay. Now India, my point is India is also looking at political prestige, right? If you look at the assessments I talked about, we have a whole huge gap in the military part of space. We need to increase our satellite capability by 10 times or 15 times. I think the numbers I have, we should have at least 60 or 70 operational military satellites. Can be communications, LNT, remote sensing, TDRS, weather, right? You put them for navigation, you need a whole host of it. We should look at that because my point would be that would be the highest priority I would give. The civilian part, ISRO is doing something, but we need an industry, right? I told you about Elon Musk. One company in the US has completely become the dominant company in the world. So Elon Musk will tell the US what to do. He is so powerful. And he is one guy. He has 1,664 satellites alone. Right? I can't believe that number. I thought I'd made a mistake in counting. But it's actually true. So my point is the industry part of India should become the pushers of all the communication satellites, remote sensing satellites. I talked about applications, even to do the kind of stuff that we did, right? We were scratching the surface. I mean, even in the military side, you can look at 100 think tanks in India doing some of this work. Right? We need trained people, not only political analysts, we have a lot of them, but we also need this combination of technical, political, economic knowledge people. Right? We need these integrators also. And a lot of work has to be done. Satellite imagery is very powerful if you know what to use it for. Right? But other sources of information are also equally powerful. We need to put them together. Not only focus on the space part, which is easy to do, but all the ancillary. See, this assessment requires also a lot of ancillary information which is available in the public domain. It has to be put together for us to make sense of it. So it requires a kind of, I don't know, we use standard. We need an application focus for a lot of this. We need to invest a lot of money in creating these capabilities, not only in government, where I feel it doesn't really flower. We need to go out and create it. Right? Industry, I think, improving a lot of this and a significant increase in scale. Right? We need to invest significantly more money. If you want my personal opinion, the manned space program is a waste of our resources. I think we can use it much more fruitfully in doing some of it.
No, sir.
Yeah, please.
Good afternoon. Sir, I have two questions. The first question is, you have showed us a table where the different constellation of satellites doing continuous surveillance on Taiwan. Like, what are the sources of it? Like, how do you collect that data?
Ah.
And the second one is, I'm sure when our adversaries is capable of doing continuous surveillance on Taiwan, it is also capable on doing on India also.
Yeah.
So how India, like where we stand with China? Like for example, if they are doing surveillance, like where do we stand? Like do India also have capabilities of doing like continuous surveillance?
Yeah, so let me answer the second question first. The number of satellites we have is far less, you can see. So clearly the ability to do the kind of thing that we are doing, that Chinese are doing over India, I don't think we can as of now do over China. It's not that we don't have the capability, it's just that we don't have the number of satellites, right? And the number of things that we need to do. So if we put and create our own constellation based on our own requirements, it's a question of scaling up and being able to get to that stage. So we need about, I would argue, 60 to 80 operational military satellites at a given point in time. We need to create that constellation. Okay, I've identified all the areas. I have a detailed book. I'll give you the reference. You can go and access that book. Okay, it tells you all the things that we need. And so you can actually get a good idea of what needs to be done. See, people like us in the outside domain can only project, right? We can't do anything. So this is one part. So what was the first question that you had? Okay. Now, a lot of this source, we have a number, I have a report, right? We have a number of reports that are generated in. So, for example, the Yalgon constellation, how we arrived at how to identify a satellite. We have detailed steps. I will make aware, that's available on the open domain. You can go and download the report. You take a look at it. So I'll give you briefly. You need to look at the satellite name. You need to look at the orbit. You need to look at the time of launch. You need to look at the inclination of the orbit. You need to look at the apogee, the perigee, right? The altitude of the orbit, the period of the orbit. We need to look at the vehicle, the launcher that put it in orbit. We need to look at the launch site, where the launch site is in China, right? All of that. So I have a detailed list, some 10 or 12 parameters. If you put them together, the data is all available in the public domain. You have to go and collect them from different sources, put them together, and then you do some simple Excel table sorting, and you can categorize them. Okay? So it's a kind of simple algorithm, but you need to know what to look for. Okay? And then you can. So then you can say this is a SAR satellite, or this is a optical satellite, this is an alien satellite.
Warning for me also. My point is, I have been going through the Chinese published training reports, the PLA. Last haven't published. American documents are available which comment on the training level of civilization. There is party informatization, that is the combat of integrated network warfare. It is very poor. You see the joint exercise they have carried out with the Russians. They are also at very rudimentary level. All right to have the capability. Translating it to the soldiers at the ground level, in spite of they have sacked 300,000 soldiers, they have inducted technical graduates, but still that informatization, that is joint command, not evident in these reports. I don't know how well we should assess based on only their technical capability.
Let me repeat. I entirely agree. I don't have any question on what you're saying. A lot of this is just what we assume, right? and it's not evident that it's actually put into practice. I have no issues with that. I think there is no question also that the US is ahead of everybody else. Okay, I don't think there is any question about that. I have only one point. The US is worried seriously about the Chinese. I think we should also be worried. That's all.
Yeah, one other point is fleet operation.
Yeah.
The aircraft carriers have not carried out fleet operation in Pacific or in Indian Ocean. They haven't come out in full-scale fleet operation. Otherwise, you can't use an aircraft. Able to tell them.
See, I have to confess, I do not know enough about naval operations and fleet operations. I can only look at the architecture and say something about it.
Thank you. Thank